Hi all. In today class, we are going to see types of defibrillator. Okay, so here we have two types of defibrillator. They have been classified generally in two categories. One, if you one is based on electrode placement. So if you are placing electrode outside of the body, then it is called external defibrillators. And if you are placing the electrodes directly against the heart, then it is called internal defibrillators. So that is the based on mode of application where you are making contact with electrodes, where the electrode is making contact with the heart. It has been classified into two types. One is external defibrillator, another one is internal defibrillator. So next classification is based on the what type of current actually you are administrating. Okay, so if you are giving AC type of current, then it is called AC defibrillator. If you are giving DC current, then it is called DC defibrillator. These are two major classification. One is mode of application, and the second one is the type of current you are using. Okay, so now we will see the AC defibrillator. Okay, the AC defibrillator, we usually give the current in the range of 5 to 6 amperes of 60 hertz for the duration of 250 to 100 milliseconds. So this type of defibrillator is highly recommended for atrial fibrillation. As I said before, you have two types of fibrillation. One is atrial and ventricular. These any type, irrespective of any category, whether it's atrial or ventricular, the immediate action treatment is must needed in order to recover the normal heart function. So if you are going with AC, then it is better to treat for atrial. This AC defibrillator is highly recommended for atrial fibrillation. What could be the disadvantage of using this particular defibrillator in the sense? That is a high chance of getting ventricular fibrillation. The reason is that here, even though you are using to correct or rectify the problem of atrial fibrillation by means of AC defibrillator, it may end up with the patient to get ventricular fibrillation. So, because of this disadvantage or the drawback, what the AC defibrillator poses, um, and this type of defibrillator is not highly recommended. Okay, that is the reason they have come up with the next solution to recorrect this problem what the AC defibrillator is having. The result is the solution is DC defibrillator. Okay, so without any reason there won't be any innovation, right? So there will be purpose for each and every innovation. So first they have started with AC defibrillator to correct the atrial fibrillation, but due to the drawback of due to this drawback, the person is having high chance to get ventricular fibrillation, so it is not highly recommended. So they started to think in other aspects, why can't we do with DC defibrillator? So they have started DC defibrillator. So in next class, okay, so in next class we will be discussing what is defibrillator in detailed everything. Before that, we will see what is the principle of defibrillator. Okay, so for that, first we will see the schematic diagram of defibrillator. You know, defibrillator is one device. It's going to store some amount of energy. So then, whatever value we are setting or we are selecting, that energy is going to deliver. So storing and delivering. So that is going to be the function of defibrillator. So that is one component. That is one component. It's going to store one energy and dissipate energy. That component is nothing but capacitor. Okay, so that is going to be the main component if you take any defibrillator design. Okay, so the capacitor is one of the component. It's going to be it's going to be play a very big role in designing defibrillators. Okay, so then you need a transformer. Okay, you know why the transformer is needed. Okay, so anyway it's a DC defibrillator. We have to convert the AC defibrillator into DC type. Okay, AC, we are going to get supply from the mains, that is 230 volt here. This 230 volt we have to convert into DC. Okay, so for that you need set of components requirement in while designing the defibrillator. So you are taking a transformer. So you are taking main supplies from the um, by means of transformer. You can use any type of transformer, for step up transformer, step down transformer. These type of transformer will regulate or modulate the main voltage. If you are using step up transformer, it will manipulate your voltage into higher level. If you are using step down transformer, if it is 230 you are giving, means it will step down into 120 or something. If you are doing step up, means 230 will goes to 440, like that. So based on number of windings we are using, it will modify in that range accordingly. So that is the purpose of using the transformer, in order to regulate the main supply. Then at the output of the transformer, again you will be getting AC supply. Anyway, here we are going to design DC type of defibrillator. So this DC AC voltage, the AC alternating current have to be converted into DC, so that only the component of capacitor will charge accordingly. So for that converting, we have a diode here. So this diode is going to convert AC into DC. Okay, so here then you have a switching option. Okay, the switching option is here. The one is the point A, another one is the point B. So initially the capacitor is being connected with the point A. The reason is that first, whatever value we are setting, that up to that the capacitor has to be charged. So whenever it has to be charged, the point the capacitor point will get connected to the A. So at the time the capacitor will get charge up to its capacitance level, to the and it means that up to the whatever the input voltage we have fixed. Okay, till then till that the capacitor will keep on charging. Okay, once it reached their threshold value, so it is equalized to what the input voltage we have fixed. Then yeah, all the energy is being stored inside the capacitor. So when we have to discharge, like when we are we have to give, when we are giving shock to the patient, at that moment the capacitor point will get connected to the point B. So this now what will happen, the point connected to A will get disconnected, and the point will get connected to the B. So through this point B, whatever value is being stored in the capacitor, everything is slowly get discharges, and by means of electrode it's been transferred to the patient. That could be chest or heart, whether it is direct type or indirect type, it's being transferred to the patient. Okay, the reason of having this inductance is that in order to remove the noise, and also in order to have some inducing in order to induce some time period. Okay, instead of giving shock at rapidly, here due to some inductance property, this shock is being delivered gradually. That could be the one reason of having inductance component here, inductor component here. The second reason would be it will also remove or restrict some kind of noise here. Okay, so that would be the second reason. So that is the reason we having the inductor here. So this is going to be the overall the basic schematic diagram of designing DC defibrillator. So once again I'm repeating, the major component of designing the defibrillator is capacitor. That is the main component. Second one is we having transformer in order to regulate or manipulate the main supply voltage, that we have to convert into that voltage, we have to convert into DC in order to charge the capacitor. For that we have another component, that is diode. That diode will be converting AC into DC. And next we are having what inductance. The inductor is here the reason to have inductor means like first to remove any kind of noise which is inducing in second stage, or second one is in order to give addition timeline. Okay, to give the shock gradually instead of giving rapidly. So due to that I will act as like timing circuit. Okay, that is the main reason we have inductor here. And then through inductor, the by means of electrode, all the whatever the current or whatever the energy we have fixed to be delivered, everything will be slowly gradually delivered to the patient at a prescribed time. So that is a generalized block diagram of defibrillator. Thank you.